Factoring. 35 is 5 times 7. That's how you factor. Is that number a prime? Would you like to tackle that problem by hand? I made it up, and I made sure that it was odd, and didn't end in a 5, so that you wouldn't instantly say, well, yes, of course it's factorable. I also made it up so that the sum of the digits is not divisible by 3. So that trick that you learned back in elementary school is not available to you. Now, if you wanted to proceed systematically, what would you do? You'd say, okay, I remember the trick from high school, maybe you learned it in the 3rd grade, that a number is divisible by 3 if and only if the sum of the digits is divisible by 3. Well, you can add up the digits and see quickly, just by keeping track of the residue class, that it's not divisible by 3. So then you don't even try 5, because if it's divisible by 5, it ends in a 5 or a 0. That doesn't work. What about a 7? You would try a 7. That won't work. You could try all the numbers. There's a lot of numbers. You think so? You want to bet? You want to bet? You want to bet a computer can do that many things? That's a big number. Okay, I got 25 cents right here. Yeah, I'm going to bet you that you got a really good computer? No. Okay. But, yeah. 25 cents, just to show you how certain I am. I don't again, that's a big number. Computers don't do that many things. Even things that they can do very quickly, they don't do that many of them. Okay, well, but what happens if I told you the answer was no? Would you believe me? Why? What kind of reason is that? Haven't we learned something about the voice of authority not always being right? And maybe from time to time I would tell you something that wasn't quite right just to keep you on your toes. But if I just told you that number is not a prime, would you believe me? You would believe it. He trusts me, but you don't. That's okay. So the point he's making is that show me. Okay. But what happens if I told you that this number is divisible by both 11, which is a prime, and 293, which is also a prime? Now would you believe me? Why? Why? He said yes. He said he'd believe me. Why?
I don't know.
How long would it take you to divide that number by 11 by hand? By hand. When I was a kid, that's what I did for fun. I got a big grocery bag, the big brown cardboard, not cardboard, but paper bags, tear them open, get myself a big piece of paper, and I write a long division problem down, 25 digits and then 47 digits, and I would do long division. I can divide that number by 11. I bet you we could do it together. I mean, a big piece of paper. In 15 minutes, 20 minutes? Now that we can do, because you don't have to do all the numbers less than that. You just have to do something for each digit. And there might be, 50 digits? I can do 50 things. Computers can do them faster than I can, but I can still do 50 things by hand. So I could do the long division by 11. And it'll work, trust me. Now I got a slightly smaller number, not much smaller. Now I can divide that number by 293, and I can do that by hand. We could do that by hand together. Okay, and that will also work. But now, here's the final answer. And to get this, I used a mathematical software tool called Maple. There are two very popular, commercially available tools. One's called Maple and one's called Mathematica. And I encourage you to experiment with them. They're on all Georgia Tech computers that are owned by the School of Mathematics. So every one of our laboratories, they're available for you to use for free. You can also purchase, and I'm not pushing this, them at a student rate, which is really, really cheap. But it's quite a useful tool. And here, what I did is I took that big long number and I fed it into Maple and asked it to factor it. The specific command is I factor the number in parentheses followed by a semicolon, bam. And Maple factored that in about 1/10 of a second. And so when the output is written this way in Maple, the 11 times 293, that next number, that's a prime. That's a prime. Now you would get the number in a few minutes with hand calculations. But now, how long is it going to take you to convince yourself that that final number is a prime? And how can I trust Maple? It's a computer program, by the way. How can I trust it? Did it try everything? That's something I'm going to have to think on. Slightly harder problem. What fate would befall an individual who was able to factor integers with 200 digits? And what about things that were that long? And then I asked, who cares? And why are you borrowing money, paying money, whatever, to go to Georgia Tech, one of the nation's best universities, to consider questions like this? How dare a professor of mathematics at Georgia Tech to waste your time on issues of can you factor big numbers? Well, let me answer for you the first question. What fate would befall someone who is reliably able to factor integers with 200 digits? That person is at great risk, and some very nasty people in the world will try to kill them because they are able to unlock what is called public key cryptography. And they would personally have access to valuable national and industrial secrets, which are kept very close to the vest all around the world, in countries that we like and in countries that we don't like. That person should be hidden and protected because they have a power that enables them to do things for good and for bad. That's pretty scary, isn't it? Just on the basis of being able to factor? Question. So are you like a mutant? I don't know whether to be a mutant, but if somebody, and by the way, the threshold is less than 200. It's around 130 digits. Very sharp threshold, by the way. 200 digits is out of touch, probably in my lifetime, probably in yours as well. So who cares? Everybody cares. Everybody cares. And I'm not wasting your time, not at all. This kind of mathematics is fundamentally important to your education and to your studies as a computer scientist, as an engineer, as a mathematician. And this kind of thinking will serve you very well in the years to come. So you're paying money for very good reasons.